Professor Ben Newell is a professor of cognitive psychology and deputy head of the School of Psychology at UNSW Sydney. His research focuses on the cognitive processes underlying judgment, choice, and decision-making, and the application of this knowledge to environmental, medical, financial, and forensic contexts. Ben Newell has worked with industry and government partners on projects including climate change communication and retirement wealth planning. A key theme of much of his work is overcoming the myopic thinking that tends to cloud our judgment when we're making decisions about an uncertain future. Ben is a member of the academic advisory panel of the behavioural economics team of the Australian government. And his talk today is entitled "From Why Should I Bother to Yes, We Can, Risk, Willingness, and Cooperation in Action on Climate Change." Welcome.
All right. Well, thank you very much for the introduction, and thank you for the opportunity to present at this amazing event. So what I'm going to talk to you about today are three different topics, which all, I think, are loosely connected to this idea of how we can get people to be concerned about climate change and how we can get them to be willing to take some action and realize that their actions can make a difference. So one of the issues that I think we face in trying to get people engaged in climate action and understanding the need to do something is this kind of drop in a bucket response. And what I mean by that is that people may have the tendency to say, well, why should I bother altering my behavior if I don't see, other people around me doing the same? And if I do change, then will my actions really make a difference? Is there any point in me stopping a particular behavior that I enjoy just because I think it's going to have an impact on climate change? So the three projects that I want to talk about all look at that issue from slightly different perspectives. So the first one is a lab-based task, an experimental task, where we try to look at the kinds of things that stimulate cooperative action for people, where we can put people in a situation in the lab where they have to negotiate with each other and, as I said here, simulate this kind of climate catastrophe avoidance. The second project is, and that's an experimental one. The second one is more of a survey project looking at the predictors of people's willingness to mitigate climate change and to perceive risk and to do something about it. And then the third one, if I have time to get to it, is trying to integrate some insights from behavioral science with moral arguments, the kind of arguments that come from moral philosophy for why we should be taking action and why we should care. Three different projects. I'm going to start with this first one. Let me just go back to share. Here we go. So I'm going to start with this first one, creating situations that lead to successful cooperative action by simulating climate catastrophe avoidance. This is work with Mark Holston, who's currently at the University of Lancaster. So the aim in this project is to get people to engage in a game in the lab that's kind of something like a climate negotiation. It's obviously not exactly the same as a climate negotiation, but we try to include some aspects that are similar. And arguably, the main goal of climate negotiations is to prevent dangerous anthropogenic interference. But one question then is, well, what counts as dangerous? Is it 2 degrees? Is it 1.5 degrees? There's often uncertainty around the threshold that we're trying to avoid. And we know from lots of other work that uncertainty can often be an impediment to action. So I've done some work in previous years with other colleagues looking at how uncertainty about the science, even though it should actually mean that we should be more active and more concerned and do more about it, can often be an impediment to action on climate change, because people say, well, I don't really know, and so perhaps we don't need to build the wall or whatever it might be. Similarly, in this article at the bottom here, I've done work looking at the role of psychological distance in people's perceptions of climate change. And one of the factors that comes into psychological distance is this notion of hypotheticality, or uncertainty about whether these impacts are going to occur. If I'm uncertain, then that gives me another way of distancing myself psychologically from having to do anything about climate change. So uncertainty can be this impediment to action. But in this project, we're focusing specifically on how uncertainty about thresholds can affect negotiation. And we do this by building on a lot of previous work started by Malinsky and colleagues using a game called the collective risk social dilemma. So I'm going to spend a bit of time explaining what that is, and then I'll go through what we did with that game. So in this collective risk social dilemma, we have 6 people in a group, and they interact anonymously via computer terminals. So there's no discussion going on. They're just seeing responses come up anonymously from other people in the group. They know that there's others in the group, but they don't know who they are. The goal of this group is to prevent damage by investing in a joint resource. And in this game, it's the money in a communal pot. Each person starts with $40, and that's their capital that they have to begin the game. So that each person gets exactly the same amount at the start, and that's what they have to try and invest in the joint resource. Then on each of the 10 rounds in this game, each person chooses to invest either nothing, $2 or $4 from that starting capital. And the way the game works is that if the total investments for all 6 players exceed the threshold at the end of 10 rounds, then each player receives all of their remaining capital. But if the total investments for those 6 players fall short of that threshold at the end of 10 rounds, then each player receives only 10% of their remaining capital. So for example, if I decided to invest $10 across the 10 rounds, then I'd end up with $30. And if we exceeded the threshold, then I would walk away with that $30. If we fail to exceed the threshold, then I'd only walk away with $3. So you can see that in the context of the game, there's a fairly significant impact financially for each player. As part of the game, the players make they have to do 3 different things. So first of all, they make a proposal, and this is how much they think we as a group should save in total. They then make a pledge, which is how much I say I will contribute in total across the 10 rounds. And then on each of the rounds, they make a contribution. So how much I actually am going to contribute across each of the 10 rounds. So the question now is, what's the threshold? How do we define the threshold? What's the goal that people are trying to achieve to prevent this damage from occurring? Here's the basic overview and design of the experiment that we ran, and the threshold varied as a function of the condition that people were in. So these treatments here are between subjects treatments. So there's a separate group of 60, so 10 times 6 groups in each of these treatments. And the way that we described the threshold was different in each of these treatments. So in the first one, we call the certainty treatment, everybody knew that the threshold, the amount that they had to achieve in the communal pot was $120. And if they managed to achieve that, then they walked away with their remaining capital. In the uncertainty condition, all they knew was that the threshold lay somewhere between $0 and $240, but they didn't know at what point it was going to be in that range. We then had 2 groups here, and this really comes to the main aim of the experiment, which was to see how contributions would be affected, how uncertainty would be managed, if we gave people a kind of early warning signal as to where the threshold might be. So you can think of this as akin to getting an update from the IPCC saying, well, now we think actually it's not 1.5, it's 1.25, or you know, being more precise on what the threshold tipping point estimate is. Of course, there may not be a specific tipping point in the climate system, but this is the idea that we're working around. And so in the warning wide condition, for the first 5 rounds, they're completely uncertain, just like in the uncertain group. But then between rounds 5 and 6, an announcement is made to everyone saying, okay, the threshold is now going to be somewhere between $84 and $156. So it's significantly narrowed the threshold, but it's still quite wide. In the warning narrow condition, the announcement after rounds 1 to 5 tells them that it's now going to be between 108 and 132. So now they've got a lot better idea how much they're going to need to save in order to avoid this catastrophe. So you can see that the expected value of the threshold, the expected value at which the threshold will occur is equal across all of these groups, even after you've been given the threshold information. And I'll return to that a bit later on. So the other thing to note here is that pledges and proposals are made twice in our design, once before rounds 1 to 5, when everyone has the same amount of information, and then again before rounds 6 to 10, once the warning groups have had their initial warnings. Okay, so there's a few different ways we can look at the data from this experiment, and I'm going to go through a few different data figures and analyses here. But before I get to that, I'm just going to explain again the structure of the game, just so everyone understands. So what this little diagram is illustrating is that we have our 6-person groups. So each of these squares is the idea that there are 6 people in a group. Each of them are making a proposal as to how much they think the group as a whole needs to save in order to avoid the catastrophe. So in this group, we've got a range between 100 and 150. There's then the pledges that I say that I will make across all 10 rounds, and this red dot is the sum of those group pledges. And then there's the contributions that I actually make per round, and that sum of those per round is the yellow circle here. So we go through our 5 first rounds, then we do that process again in round 6, and then we go through to the end of round 10. And at the end of round 10, the computer then determines what the exact threshold is going to be by drawing a random number from a uniform distribution over the relevant interval. So if it was in the fully uncertain group, it would be over the interval 0 to 240. Okay, so hopefully that's clear as to what people were required to do. One other aspect is that these pledges and the proposals and the contributions are all made simultaneously. So I can't wait to see what other people in the group are saying or what they're doing before I make my own proposal. It all has to happen straight away, but it's once everyone has put in their information privately, then it's all made public. So I can see at the end of the round how much other people have been contributing and how much they've been pledging and so on. So in that sense, it's trying to capture that way that negotiations occur. Okay, so the first data slide that I'm going to show you is how much groups contribute in this process. So what this slide plots is the average group contribution broken down by rounds 1 to 5 and rounds 6 to 10 for the 4 different treatments of relative uncertainty that people have. So if we look at the first bars over here, this is T1. This is when I know what the pot needs to be at, 120. And the average group contributions are around about 60 in the first 5 rounds and round about 60 in the second 5 rounds, which means that they're on track mostly for hitting the target. They're going to get to 120. And the rounds 1 to 5 contributions are pretty similar across the 4 treatments, which is what you would expect because everyone has pretty similar information at that point. Where things start to change is when we look at the contributions made in rounds 6 to 10. So we can see, particularly in the group where the threshold is very uncertain, that it appears that groups are banking on it being a lower than the expected value amount because their contributions start tailing off dramatically in round 6 to 10. You also see that effect occur in the wide uncertainty group. So these are the guys that get the early warning signal, but it doesn't seem to help. It doesn't push them to be saving very much more. In contrast, in the group that get the narrowing, the really narrow signal, then you do see some evidence for an increase in the contributions that people are making. So this is a first suggestion that there may be some positive effect of giving that early warning signal. But as we'll see in a moment, it's probably not going to be quite enough to shift enough groups to avoid the catastrophe. Just to dig a little deeper into what's going on in this bar here, this rise in contributions, we can see if we break down now the number, the average contribution per group across the round, so across each game. So that's what this is plotting here. This is now the average contribution per group, and this is the round of the game. And we can see that there's an uptick after game 6 or in game 6. Can I just ask, can people see my cursor when I'm moving it around?
Try moving it around now. Yeah,
Like
I see it.
Yeah. Okay, so this data point here, this is the contribution, the uptick in contributions after they get that early warning signal. So we can see that it is having some effect, but then it doesn't really persist throughout the rest of the trials. It starts to drop off again quite precipitously. So there is some immediate information of that warning, but it doesn't seem to persist, at least not across all of the groups. Okay, so that's what's happening in terms of the contributions. Now what we want to know is how many groups avoid the catastrophe. And I'm going to go through two different ways of looking at those data. One of which is maybe a bit more glass half empty, and one which is maybe a bit more optimistic, glass half full. So in this method, what we're going to do is calculate the probability of avoiding catastrophe according to the treatment or the condition that people are in. And we're going to do that using this basic formula here. So this is the probability of the group avoiding catastrophe. And it's either 0 or 1 if the contributions, if the amount that they save is either greater than the minimum or less than the minimum or greater than the maximum. So if it's less than the minimum, the probability of excluding it is going to be 0. If it's greater than the maximum, then the probability is going to be 1. And if those two things are not true, then we can calculate their probability of avoiding it by looking at the amount that they save minus the minimum threshold for their condition divided by the difference between the maximum and the minimum in that threshold condition. So as a worked example here, what we can see is if a group contributes $125, then the probability of avoiding catastrophe in the certainty condition is going to be 1 because the threshold is 120, so they're clearly going to exceed it. In the uncertainty condition, we substitute in the min and the max thresholds into our little equation here, and that gives us a probability of 52% of avoiding catastrophe. So if I save 125 and the threshold is going to be somewhere between 0 and 240, then I only have a 52% chance of avoiding the catastrophe. And you can run the same numbers through the wide and the narrow by substituting in the min and the max thresholds for those conditions. So this way of looking at it is kind of saying, well, you know, you've got one roll of the dice here. Let's see whether the amount you save is really going to secure, to increase the probability significantly of you avoiding that catastrophe. And here's what the data look like for each of the 4 conditions when we apply this probability of avoiding catastrophe. So what we've got plotted here on the y-axis is that probability that I just showed you on the previous slide of how to calculate it. And these are the 4 conditions for treatment. So what we can see over here is that the vast majority, each dot here, by the way, is a group. So a group of 6. So remember, there are 10 groups of 6 people in each condition. So what we see over here is that 9 out of the 10 groups in the certainty condition did manage to avoid the catastrophe. 1, however, didn't. So even though they knew what they were saving for, they knew that there was a significant financial implication, they didn't manage to get there. When we move across into the greatest level of uncertainty, we see that this probability dramatically drops. So now having that uncertainty in place, even though you've had sort of 10 rounds to achieve it and you've been able to see what other people have been pledging and contributing, it doesn't really help. It doesn't push the average probability above 50%. So the vast majority here are really in a serious problem. The same thing is happening for the T3 condition. So while there are now a bit of a spread of probabilities of avoidance, it's still on average not really pushing people up to the point where they're going to avoid it. And then finally, in the T4 condition, it's a sort of a glass half full, glass half empty. So you can see that giving that narrow warning, really narrowing down where the threshold is going to be, does push some of these groups up into the higher probabilities of avoiding catastrophe. And it's certainly better than not having any kind of warning at all, but it's still not fantastic. And in fact, if you do the statistics on this probability here is not significantly different from these two. So although the warning pushes people up, it doesn't make people really avoid that catastrophe. So that's one way of looking at avoiding the catastrophe. The second way that we can look at it is to just examine the percentage of groups who avert catastrophe at different hypothetical thresholds. So this is kind of akin to saying, well, we've got multiple rolls of the dice and we can see what happens if the threshold, the tipping point, is actually at these different values. And this allows us particularly to focus on what the expected threshold value is going to be across all the treatments, or the actual or the expected, which is the $120. So when we look at the group's contributions in that way, we can see that, so what's plotted here is the percentage of successful groups on the Y. So how many groups actually avoided the catastrophe if the threshold had been at these different values, the hypothetical threshold. So if the threshold had been at $40, then everyone's a winner. Okay? Everyone avoids the catastrophe. That's great. As soon as we shift to 60, at least one of the groups here in the full uncertainty condition is going to fail. So one of the groups didn't even save $60 by the end of it. And then you can see as we go across these hypothetical thresholds that on average things are dropping. The interesting case of the 120, which is the expected value one, we can see, and this is where the glass is a bit more half full, that in this narrowing of the uncertainty treatment, we see a relatively large impact of being given that information. So one way to think about this is it's kind of doubled the percentage of groups that have avoided catastrophe. Here for the fully uncertain, it's right down at around 25%. Here it's up above 60%. So it's more than doubled the number of groups, which is a positive thing. However, if we look just past that expected value threshold to 132, and remember that this is now the known top limit of the threshold for the T4 treatment. So they know for sure that it's not going to be above 132. It wouldn't really require very much more per trial to save to hit that target. And yet only 2 of our groups managed to get there. So it's useful getting this early warning signals. Is it going to be enough in the context of this game? It seems not to be. One final piece of data that we can look at from this study is to say, is to look at the difference between what people say they're going to do and what they actually do. So this is now the relationship between the proposals, the pledges, and the contributions that people make in the 4 treatments. So proposals in blue, pledges in red, and contributions are in yellow. And this is the average of the group decision averaged across the pledges and the proposals in rounds 1 and rounds 6, because they're pretty similar. So we averaged across them. So you can see that in the certainty treatment, all of these values lie pretty closely on top of each other. So that people are doing what they say they're going to do in the certainty treatment. But as the amount of uncertainty in the threshold increases, so does the disparity between these dots also increases. Where right over here, in the fully uncertain, we've got people making a proposal that's in line with just about all the other groups, so around the 120, around the expected value, but then their contributions fall way, way below that, and their pledges are somewhere in between. Similar kind of pattern happening in T3. T4, this is where we see the uptick and the increase in contributions, and you can see that that actually changes the ordering of these dots in terms of the contributions and the pledges. So here, in this treatment, they're still making an average similar group proposal, but there's a bit of an increase in the contributions that they make that we saw coming into round 6. But as we've seen in the last 2 slides, it's not really enough to push enough of the groups high enough to avoid that catastrophe. So a summary, some take-home messages from this first study are that threshold uncertainty can be debilitating for successful avoidance of catastrophe, that these early warning signals, narrowing of the threshold helps, but arguably not enough in this repeated decision game. And one of the things I didn't go into is that there's been other very similar work looking at these kinds of early warning thresholds, but not in these repeated decision games. And so we're particularly interested in how seeing what people did on previous rounds then changed people's contributions. And one of the things that seems to be happening is that there's this almost kind of self-fulfilling, debilitating effect that once you're on a trajectory that doesn't look like you're going to hit the target, then more and more people seem to give up and not contribute. We find some evidence that these early warning signals are helping, but if they're insufficient or impossible, if we're unable to actually, in the climate context, give an early warning signal that is that precise, then we might have to think of separate tactics. And so things like trade sanctions, for example, have been discussed in previous work. So that's the end for that project. I'm happy to take any questions on that one, or I can carry on with the next part of my talk, if that's...
So for now, I don't see questions in the chat. I had a question. I don't know if you've been able to look at that, but did like who the people were in the group affect their behavior?
We did look a little bit at that. So we took some measures of things like discounting, temporal discounting, and some measures of kind of financial literacy, impatience, I think we had. Nothing really showed up as significant predictors of the variance in contributions. So I don't have a good answer to that.
Okay, well, that's interesting. Okay, well, we don't have any more questions at the moment, so I suggest you carry on and we'll have more at the end.
Great.
Oh, wait, there just one popped up. Nicola asks, how close do you believe this individual and group behavior can mimic the complex negotiations of state and non-state actors on an international level?
Good question. And I'm not sure that I can quantify the proximity, exactly how close, but I appreciate that, lots of the aspects of this game simplify what the real negotiations are like. And I think we're trying to focus in particularly on this aspect of uncertainty around the threshold, but there's lots of other things going on that could change the way the negotiation plays out. One thing, for example, is that everybody starts in this game, everybody starts with the same endowment. So they all get $40 to begin with, and it might be different if you have state and non-state or different countries who have different amounts to contribute to the pot in the first place, and that might create asymmetries in the contributions that people make as well. So those are interesting kind of changes that one could make. But I think it's always, as in any kind of experimental work, you're approximating some of the processes that you think are fundamental and interesting, but you can't have a complete model of the world in your task.
Thank you. Just a suggestion about the live transcript problem. It's possible that if you stop sharing your screen for a second, you will have the option to remove them, and then you can resume sharing the screen.
Okay, I might just try that.
Okay. At the bottom, do you see live transcript somewhere or CC?
Yes. Yeah. Okay, perfect. Hide subtitles.
Yeah, perfect.
All right, let's go back to sharing. Okay, is that all right? Everyone can see it again?
Yeah, it's perfect.
Yeah. Okay, so I'm now going to move to the second project that I want to talk about. This is a survey-based study. This is work done with Belinda G, who was a student and is now working for the behavioural economics team of the Australian government. Brett Hayes, who's a colleague of mine here at UNSW, Rachel McDonald, who was a postdoc here and is now at Columbia, and Marilyn Brewer, who was also at UNSW and is now retired. And this work was primarily trying to examine the much talked about kind of gap between people perceiving risks, people being willing to take some action, and people actually engaging in that behavior. And the main thing that we're focused on here is this relation between risk perception and behavioral willingness, and what are the predictors in the climate context of those two things. We don't look at actual behavior in this task, and we acknowledge, that this relationship between perception, willingness, and behavior is not really linear in the sense implied here by the arrows. It's often that maybe we perceive risks, we have some willingness to do something about it, but our actual behavior is even lower down. There's that gap between wanting to do it and actually doing it. So this is a paper that came out a couple of years ago now. So the data are a little bit old, but I think still relevant, and there's still some important lessons to take from them in the way that we can try to understand risk perception and willingness to act. So the sample that we have is about 1,000 Australian adults. This was a completely online survey, and our main task was to look at what the predictors are most important for risk perception and behavioural willingness. And the idea was that we could then make some kind of evidence-based communication suggestions. How should you be talking about climate change to engage people and get them to act? The work built heavily on Sander van der Linden's model of climate change risk perception that he published in 2015. And that model focused just on the risk aspect, not on the willingness aspect. But what van der Linden did in that paper was to look at existing measures of climate change knowledge, of people's attitudes towards climate change, people's understanding of the different predictors, different causes, different solutions associated with climate change, and then see how they fed into risk perception. So we took that as our base start, and then we added in some additional measures to look at behavioural willingness. So the two main questions that we're asking are about risk perception firstly, and we were asking people that in the following way. So questions like, how serious would you rate current impacts of climate change around the world? How often do you worry about the potentially negative consequences of climate change? How likely are you sometime during your life to experience serious threats to your health or well-being as a result of climate change? Second thing we were asking primarily about is behavioural willingness. And for that, we had questions like, what society should be willing to limit the amount of greenhouse gases that companies can produce without paying penalties? Would you be willing to pay more for electricity? Would you be willing to make donations to environmental groups, et cetera, et cetera? And these people were just indicating their willingness on this scale from 1 to 7. So these are a kind of schematic of the different factors that we were looking at as potential predictors of both risk and willingness to act on climate change. So I've grouped them here into their sort of similar constructs. We've got demographics, we've got cognitive factors, we've got experiential factors, and we've got socio-cultural factors. And these were the groupings that van der Linden had in his previous paper. We added a few things in, as I said before, so things like inefficacy and free market ideology were things that we added in to look at this willingness question. So I'll go through now first the risk perception. So asking people about risk perception, what comes out in our model as strong predictors of risk perception. The main things that we see, and this is through doing a hierarchical multiple regression and seeing which things basically account for the most variance in the model. And I'll show you a little bit more. I'll show you a table of that right at the end. The main things that come out in predicting risk were affect, inefficacy, so the perception of whether or not things that you could do would actually help, and descriptive norms, so whether or not you perceive people around you as taking these kinds of actions. If we turn to willingness, so questions like, would you be willing to support a political candidate, etc. We also see affect and inefficacy coming out here as important predictors. But now we see prescriptive norms being important in predicting willingness as well. So that's the perception of what you think people should be doing, what you perceive people are telling you, this is what you have to be doing. We also find in the willingness that descriptive norms also play a role, free market ideology also plays a role, as do biospheric values. Those, you know, your kind of environment, the amount that you value the environment seems to have an important role to play in predicting willingness. So why might we see this pattern of effects? Well, the affect that we see being a strong predictor kind of makes sense in the risk perception, that if we're assessing affect through questions like, I see climate change as something that is on a scale from very pleasant to very unpleasant, and we're predicting risk from that, then it's unsurprising perhaps that we see that kind of experiential affect as being an important predictor. Why is that happening? Well, because affect and attitude might guide information processing and judgment. I'm not a big fan of kind of dissociating emotional and cognitive influences on decision making, but I think that it's clear here that having some affective component and feeling that emotional response does seem to guide the way in which you can process information about climate change and the judgments that you then make of its potential risk. It may also translate into this notion that you can more vividly imagine the risk. How about this cognitive aspect? Well, as I said, the thing that seemed to be important was the inefficacy. The knowledge was also partially important, but mostly just to do with the solutions. So understanding what appropriate solutions might be for addressing climate change. Knowledge of the causes and impacts in our sample didn't seem to be as strong a predictor. And again, if you know what the appropriate solutions are and you perceive those actions to be necessary and effective, then that could contribute to your seeing the risk and being willing to do something about it. Why is that the case? Well, you're not going to advocate for action if you don't know what the appropriate action is, and you're not going to do that unless you believe it will work. So in our sample, if you were endorsing statements like these ones on the screen now, if you truly believe, we cannot take strong action on climate change because other issues should take priority, or whatever we do as a nation won't make a difference, then obviously you're not going to be particularly willing to do anything about it. So overcoming that sense of inefficacy turns into an important part of the problem. And I think, linking back to my central question at the start about how do we overcome that drop in the bucket response. So we've seen in the previous set of studies that we need to try and reduce the amount of uncertainty about the target that we're trying to achieve if we want to overcome people's reluctance to do enough. Here we're seeing the same kind of pattern, right? If I get the sense that my contributions are going to help, then that overcomes or increases my willingness to do something. And then the socio-cultural aspect that came out, we find that if you perceive that others are acting, so a kind of descriptive norm, or you perceive that others expect you to act, so the prescriptive norm, that helps. If you have these stronger biospheric values, respecting the environment, and if you think that markets can function without government intervention, so this is the free market ideology questions that we ask. So if you believe that markets can function with some government intervention, that they shouldn't be left alone to sort of run freely, then that also increases your willingness. And you can, again, kind of explain why those things might be happening. Well, our beliefs are going to be influenced by others, by society and culture. We can be motivated to act in line with others. And there may be some dissonance between belief in free market and climate action if you perceive actions to be taken that are reducing the ability for the market to act freely. This is breaking down those results in the explained variance amongst all the predictor variables in our extended model. Really what I'm highlighting here is that in our sample, at least, some things, the things highlighted in blue, didn't really seem to explain much of the variance. Surprisingly, perhaps the party affiliation, so whether people were right or left wing, didn't seem to have much influence in our sample. This mitigation response in efficacy is the thing I've been talking about. That did matter quite a lot, as did affect, as did descriptive and biospheric, descriptive and prescriptive norms. The other thing that we can see here is that the overall variance explained is pretty high for the risk perception model, and this compares to a value of about 68% of partitioned explained of variance explained in Van der Linden's study on a UK sample. But our willingness model explains less than that, which suggests that there's more going on that we're not tapping into, that we need to include if we're going to predict behavioural willingness more precisely. But just taking out the sort of 4 things that we can see as being important in our data, we've got affect, inefficacy, descriptive, and prescriptive. So if we just think briefly about how that might translate into messaging and talking to people about climate change, then it would suggest that emotional stories and imagery are going to be useful, engaging language, relatable messages, but we also need to avoid that kind of climate anxiety, that spiraling of despair. And one way to do that is to discuss solutions when discussing the problem. So to get over this inefficacy issue. So we need to emphasize the feasibility of solutions and convey why action is needed. And I've got a particular point here about Australia, because what we often hear in the media over here and from certain political persuasions is that, you know, Australia, even if it did act, it wouldn't really make much difference because we only contribute 1.3% of total global CO2 emissions or greenhouse gas emissions. But that avoids the fact that we're one of the highest emitters per capita in the world, and that we are a huge exporter of coal. And so getting that message across and realizing, okay, so we can make a difference because we are actually a big player is important. Descriptive, so make your actions visible, make your action the norm, tell your friends, your family, your colleagues, influence your social circle. And prescriptive, I encourage them to take action with you. So realize that this is something that you should be doing. And one way of sort of linking that to I guess recent events to do with climate change action. So this paper, we were writing it, it came out around the time of one of the big schools strikes for climate in Australia. This article over here was a piece that Belinda and I, the student that was leading this project, wrote for the online publication, The Conversation, about how attending a climate strike might actually touch on some of these things that we see in our data as being important for encouraging action and risk perception. So the affect that's induced from being in a crowd of supporters, the overcoming the inefficacy by seeing lots of other people doing the same thing as you, and getting that sense that this is more of a norm behavior. And you can see that this was a link that I put up on our Slack channel in the lab group, just to sort of create the norm of going to attend the strike, and that it was an important thing to be doing. So I guess this data, you know, our survey fits in with a lot of other work in this area. I'm sure you've been hearing lots about it in the summer school, to do with, you know, getting people engaged through emotional stories, thinking about the risk, not overdoing it, talk about the solutions, show who's acting, remove these financial barriers, increase efficacy. So really to target the things that are stopping people from acting. So that brings me to the end of that second project, and I'll carry on, and then we can maybe wait for questions at the end, because the third one is short and is directly linked to what I've just talked about. So what the survey data seems to reveal to us, that there are different aspects which are stronger or weaker predictors of willingness to do something. The point of this final paper that I want to talk about is a paper that's in press, and it's work with Professor Jeremy Moss, who is a professor of philosophy here at UNSW, who does a lot of work on climate justice and thinking about, you know, the moral case for why we need to transition in a equitable way to a new form of energy, really, and to really act on climate change in a way that's going to be equitable and considers all players. And what we did in this paper, I'll just go back, is to try to sort of combine some of the moral arguments for taking action with some of the insights that we have from behavioral science that can overcome some of these barriers that we've identified in the survey, like the inefficacy, like creating the norms, and so on. One of the starting points for the discussions that Jeremy and I had about this paper actually came from a quite a well-known paper by a US philosopher, Walter Sinnott Armstrong, that's called "It's Not My Fault: Global Warming and Individual Moral Obligations." And it's a good paper. If you haven't come across this, I suggest that you take a look at it, because it's an entertaining and very thought-provoking paper. And the question, this is a quote from the paper, the question that Sinnott Armstrong poses is whether the facts about global warming give me any moral obligation not to drive a gas guzzler, so a big car, just for fun on a sunny Sunday afternoon. So I'm not going anywhere. I have no reason to actually need to drive, but I enjoy it. Is there any moral obligation for me not to do that? And the paper goes through several different kind of moral arguments as to why or why not you should go for that drive. And I'll tell you the conclusion that Sinnott Armstrong arrives at in a moment. But the point of this paper is to bring some of these arguments to the attention of policymakers. So that the paper is published, or will be published, in a journal called Behavioural Science and Policy, which is, as you can see here from their statement, it's a way of promoting the application of behavioural science that serves the public interest. And what we're trying to do is link some of these moral arguments to the behavioural science. I'll just give a very brief overview of what we talk about in the paper. So the main kind of moral arguments that we look at are what's called duty accounts, so positive duty. So if individuals can take an action to help others, then they should do so. Negative duty, if individuals can take an action to cease harming others, then they should do so. And fair share arguments, so to tackle problems that require collective effort, each person needs to do their fair share. We also, going into the efficacy idea from the previous work, look at arguments that indicate that individual actions do actually matter. So things where we can aggregate data on the effects of actions across a lifetime increases thinking about significance of small daily actions. Aggregating data on the effects of large groups of individuals can make people appreciate the significance of those actions. These are pretty straightforward ideas, but linking them back into the fair share, the positive duty, is what we're trying to do here, to sort of reinforce how persuasive these kinds of arguments might be by giving them that moral backing. So here's just one very quick example of this kind of collective efficacy. This is from a paper by Adrian Camilleri and Rick Larrick from a couple of years ago, where they just showed that if you show the impact of a particular action for one person, so this is reducing your TV usage by 20%, how much CO2 is being prevented. But if 1,000 people do this for a week, then clearly, I mean, these are numerically equivalent, but this argument with 1,000 people, they show to be much more persuasive, and they look at various reasons why that persuasion happens and what the mechanism is. It's a fairly simple way of doing it, but it has an impact. The other thing that we then go into is to look at ways we can improve the policies and policy communications in ways that kind of provide the implicit and the explicit moral motivations. Things like defaults that convey an implicit message that a default option is morally right. Policies that impose fees for undesired actions, so putting a price on plastic bags at supermarkets. That conveys the message that this behavior is undesired, it's somehow wrong, and that most people already do the desired action. So that's a sort of message that's implicit in putting the fee on it. And try to perhaps even have moral explanations for policies as well. And as we review data showing that this kind of explicit messaging can improve participation rates. And lastly, about tailoring these moral arguments to the audience. So this is showing that evidence, one size doesn't fit all in terms of different audiences. Conservative and liberal audiences can be different and can be receptive to different types of messaging. In our survey data, we didn't see that as a strong predictor in our data, but in other surveys that does come out as being important. So we go through those things, and the point I want to end on, returning to Sinnott Armstrong's paper, is that he actually ends up concluding, this is again a quote from the paper, "It's better to enjoy your Sunday driving while working to change the law so as to make it illegal for you to enjoy your Sunday driving." So he kind of comes down on the idea that yes, your individual actions matter, but perhaps the individual actions that matter are not the ones that you think they are. So driving your car, yes, the moral obligation for not doing that is perhaps not as strong as the moral obligation for actually trying to influence the people who can make change. And I think this is the point that I want to end up on, is that there has been, and it's an issue that is kind of unclear in my head at the moment, but I spend a lot of time reflecting on this, is this tension between taking individual action. And I know the topic of this session is sort of individual action, individual cognition, but how that plays into the responsibility for larger players to take action. And the reason I've got this slide up is this is a recent paper by Jeffrey Supran and Naomi Oreskes. I believe that you've heard from Naomi Oreskes earlier in the summer school. I'm not sure whether she spoke to you about this, but this paper does a text analysis of the communication that ExxonMobil, big oil company, has made around climate change over several years. And one of the things that they highlight is that the rhetoric and the framing tends to shift responsibility for climate change away from itself, so away from the company, and onto consumers. And I think that's part of the issue here that we're grappling with these ways of changing individual cognitions. Yes, they can have an effect. Yes, we can nudge people to do take different kinds of actions and emphasize the morality of acting in particular ways. But that's only going to be a part of the problem, and we need real, systemic change and change in leadership. And we need to acknowledge that it's not our fault all of the time. We have to get the balance right in terms of the players and the real influence. But that's the tension is between doing that and then saying, oh, well, then I don't need to do anything because, it's the oil companies that need to change their behavior, so I can carry on and do all of these things. It's somewhere in between that we have to try and drive the balance. And just to sort of emphasize that and to give a little plug, I did had a conversation with Daniel Kahneman just recently for an event here at UNSW. You can watch the conversation there on that link. Those of you who don't know, Daniel Kahneman, very famous psychologist and sort of founding father of behavioral economics, Nobel Prize winner. And he told me in part of that conversation, behavioral economics is not going to solve climate change. And what he meant by that was that, yes, we can have influence at the margins, essentially, on changing people's behavior in these individual decisions, or getting people on board with making those kinds of policies more palatable, but we have to strike that balance between individual action and institutional change. Okay, so the summary of the talk, we looked at that experimental task that showed that uncertain thresholds are debilitating and that these early warning signals have, in our design, relatively limited impact. We then looked at the survey that examined predictors of willingness to mitigate climate change, and we saw that affect, inefficacy, descriptive norms and prescriptive norms were important in our sample. We then just quickly went through this idea of moral arguments, actions and policy, and touched on this notion of positive and negative duties, fair share, and again, emphasizing efficacy, but acknowledging limitations and the beware of this blame shifting from the organization or the corporation or the government to the individuals. And that's where I will leave it. Thank you very much for listening.
Thank you very much. That was very interesting.